All right, so we're going to start off with polynomial functions, and we're going to start off with the simplest polynomial function there is, and it's called a power function. And a power function looks something like this. I think the book uses a p. It looks like something like k, which is a constant, times x to the p, where p is a power. Now, many times students confuse power functions with exponential functions. The really, really important thing here is that x is the base in a power function. In an exponential function, x is an exponent. That's why we call it an exponential function. Okay? Stretching or question? Okay. So whenever you see something in the form of y equals kx to the p, that's a power function. And that's it. There's no more to it. It's not like plus or minus anything. It's the simplest polynomial function there is. It's a single term that looks like in this form. Now, k and p can be any integer value. And we're going to look at some of those. We're going to look at what some of those graphs look like, and then we're going to look at how to maybe solve for a power function if you're given 2 points. And I think what I'm going to say right off the bat is you might remember last year. Do you remember directly and indirectly proportional? Does that sound familiar?
Yeah.
Vaguely. Okay. So let me do a reminder. Directly proportional means this. It means y equals kx. Okay? This statement says y is equals directly proportional. K is the constant of proportionality to x. They're in a direct relationship. If y goes up, x goes up. If x goes down, y goes away. If x goes down, y goes down. All right, we say that they're directly proportional. All right. You could also say like y is directly proportional to the square root of x. That would be this. Y is directly proportional to the square root of x. And both of these actually are power functions. What's the power here? Yeah, 1/2. Okay, the square root is the 1/2 power. And what's the power here? Oh, that's what you answered. What's the power here? 1. So both of these are power functions. Directly proportional or directly proportional to the square of x. Indirectly proportional looks something like this. Y equals k over x. And sometimes we call that inversely proportional. Maybe in science class, do you ever do like an inverse proportional sort of fit in chemistry or physics or anything like that? Yeah. For real, or are you just saying it?
I think in chemistry.
Good. Mo?
Physics, yeah.
Come on, like when the frequency goes up, the wavelength goes down.
Okay.
Like, wasn't that our last lab?
Yeah.
All right, good. Yeah. So y equals k over x is, we call that indirectly or inversely proportional. That could be true. Mo is cursed with having me twice every day. Yeah, like a lab. Like, we get to see each other for like 2 hours, which is probably like more than like you see like your parents maybe. I'm really, really sorry. I don't know what to say, Mo. Travis. Hurry up. We could also say that y is indirectly or inversely proportional to the square of x, or the cube of x, or something. Like, I'm just giving you an example. But this says y is inversely proportional to the square of x, k over x squared. So that indirectly or inversely means over. And these are actually both power functions. As a matter of fact, this could be written as kx to the what power? Try again. Negative 1. Negative 1 from Algebra 2, right? And this could be written as kx to the -2. So all of these functions, all of these examples of indirectly and directly proportional are examples of power functions. So power functions, they're around, and I think you will see these in science classes when you're looking at graphs of various things. The inverse fit, or the indirectly proportional, or the proportional fit are important. So like if we were saying F equals ma, right? The acceleration is proportional to the force. That all works like that, where the mass is proportional to the force. Okay, so what do some of these functions look like? Well, if we look at power functions, we have a whole host of like values for k and p. And if we just look at like y equals x squared, it's going to look something like that. Y equals x to the fourth, that's going to look something like that. Sort of. Y equals x to the sixth is going to look something like that. Alright, sorry. No, you're right. You're absolutely right. The bigger the exponent, the flatter the bottom is. But I shouldn't be messing with the. It definitely did not look very proportional. And this is, I'm hoping, is this from Algebra 2? Like, did you do things with like x squared, x to the 4, and you had a special name for these kind of functions? No, definitely not, because x is in the base. You call them power functions, but this specific set all have a certain property that has to do with their symmetry. Even functions. These are even because they're symmetric with respect to the y-axis. And it's no surprise that 2, 4, 6, 8, those are even numbers, right? Now, just so we're clear, like y equals x squared plus 6x minus 1, that's not an even function. It's not, you can't just look at the first term. It actually has to have symmetry with respect to the y-axis. So these power functions are even. What if we changed the k value? Like right here, k is 1. What if we made it 2 or 5 or 12? What does a number in front do? Evan? Yep. Yep. Awesome. From chapter 5. Nice work, Evan. Nope. It's a vertical stretch. Or compression if it's smaller than 1. Okay? What if we made it negative? What would that do? Yeah. Over the x-axis. Perfect. Okay. All right. We could also take a look at functions like x cubed or x to the fifth. So this is y equals x cubed. That's another power function. Y equals x to the fifth. Or y equals x to the seventh. And we call these odd functions because they're symmetric with respect to the origin. So far, so good? So look, I just introduced you to like 6 families of functions, right? They're all these functions, but they're all really based on x squared and x cubed. What if we did like negative exponents? What happens when you have like y equals x to the negative 1 or y equals x to the negative 2? Go ahead, get out your calculator, think about it, draw a picture. I don't know, this is the same as what? 1 over x. Okay. And this is the same as 1 over x squared. So go ahead, let's go get out your calculator. Yeah, I think you'll have problems when x is 0, right? So x is 0 is going to be a big problem. It's probably going to be a vertical asymptote. And this. This is the inverse fit. This is indirectly proportional. As x gets big, y gets small. As x gets close to 0, y gets big. Like, they do the inverse, the opposite. What about if we square it? Sam, do you have a picture of that?
I think it's across the y-axis.
Well, all right.
It's like that instead of flipped across.
Okay.
Diagonally flipped that. Yeah.
Something like that. Okay. And let's see. A math teacher who was here many years ago referred to the family of 1 over x's as the butterfly functions, and
It does. Cats don't have antennas.
and this as the Eiffel Tower function.
How does that help you remember?
I have no idea. None whatsoever. But if you look at x to the negative 3, that actually is very similar to x to the negative 1. And if you look at x to the negative 4, that's very similar to the x squared. So there's sort of a family of butterflies and a family of Eiffel Towers.
How do you get 1 and 4?
So if you want to get, you could do negative 1 over x. And I think that does what you want it to do. I think. I could be wrong. Does that do what you want it to do?
Yeah.
Okay. And then let's see. The other thing you could do is you could also have, you don't have to have integer exponents. You could have like y equals x to the 1/2. And just as a reminder, from algebra 2, that's the square root of x function, right? So that's going to look something like that. Or you could have like y equals x to the 1/3. And just as a reminder, that's the cube root of x function. And that looks something like that. So there are a whole host of different kinds of power functions out there. Fair enough?
Yeah.
Say yes. All right. What if we're given 2 points? What if we're given 2 points and we want to find out what the power function is? Oh, good. Look at number 2. So psyched. All right. If f of 1 is 3 and f of 4 is 6. So there are 2 ways of doing it. We can do it with our calculator, we can do it by hand. We're going to do it by hand first. All right, what's the general form for a power function? Rafi? All right, y equals k x to the p. So I can take both of these equations and put them into power function form. All right, Mo, put the first one into power function form.
1
Try again. Yep.
equals
Kx to the 1. I'll put the 1 there, but you don't have to say it, but I'll put it there just so people can see. All right, Jen, give me the next equation.
6 equals
Kx to the 4.
K4.
Wouldn't it be, yeah.
Oh, I'm sorry. Yeah, you guys you're right. Thanks. So I'll try that again. So, let's see, Mo, k times what to the what?
1.
Thank you. And then Jen, k times what to the what?
4.
All right, great. All right, so I now have 2 equations with 2 unknowns. And there are a whole bunch of ways you can solve this. You can't set them equal, but if you wanted to, you could solve one. You could use substitution. Okay? I actually have complete confidence that you can use substitution on your own. Let me show you another way that's similar to a way that we've learned before. If you take one of them, and you take the other one, and you divide them, what do you get when you divide 6 by 3?
2.
What happens to the k's?
1.
And you get 4 to the p over 1 to the p. Well, another way of saying that is that 2 is equal to 4 over 1 quantity to the p. That's a property from algebra 2. All right, if you have 4 to the p over 1 to the p, that's 4 over 1 to the p. 2 equals 4 to the p. All right, so you can do that in your head. Is that what you're saying? You know it's going to be the 1/2. What if you couldn't do that in your head? How would you solve this equation? You got it. Right? Yep. All right. So, look, it's true that when you get that, you get 1/2. All right, and Rafi and Elizabeth did that in their head. But if you had two numbers that you couldn't do in your head, you have an exponential equation and you want to get it into logarithmic so you can solve. And that would be the strategy. So, look, we know that p is 1/2. Are we finished? Say no. No. All right, so you get to pick the first or second. I don't care. What do you want to do? Second. All right, 3 is equal to k times 1 to the 1/2. What's the square root of 1? Oh, so k equals 3. So you now have an equation, y equals 3 times x to the 1/2, and that's your power function. All right? Well, we start with power functions. That's where we start. You like it because it's a lot like Algebra 2, right? Yeah. Evan, and then I'm going to show you another way.
We basically use the substitution as one to solve the power functions.
You can use substitution. Like, that will work. I sort of like the division method, but it's your choice. Did that answer your question or not really? All right. All right, so, hey, go to your calculator. So your calculator finds models as well. And if you go to Stat Edit, use the Stat button, go to Edit, you can go over to L1, and if you have something in there, if you arrow up on top of L1 and hit Clear, and then hit Enter, it clears L1. And if you go over and up to L2 and hit Clear and then Enter, it clears out L2. And now you're ready. You can actually plug in the points 1, 3. So 1 in the L1 and 3 in the L2. And then 4, Enter, 6. So you can give the calculator 2 points. If you give the calculator 2 points and you do second quit, you go back to the home screen. You can go to Stat, Calc, and then remember these are all where your regressions are. So whether you want a linear regression, a quadratic, a cubic, it does all these regression models for you. And hopefully, yeah, look at that. A power regression. So it will find you the model of the power function that goes through those 2 points. And if you hit Enter, and remember, it defaults to L1 and L2. But if you want, you can tell it L1 and L2. And then you can also, if you wanted to paste it in Y1, you can paste it in Y1. I'm just going to press Enter again. And hey, look, what do you get? Y equals 3x to the 1/2. Right? Yeah, right? So those are from first semester when we wanted to look at the correlation coefficient and we had to turn the diagnostics on. So you have to go to second 0, which is the catalog, and you have to find the diagnostics on command and then hit Enter and then Enter again. All right, and that's helpful because this tells us it's a perfect fit. R squared equaling 1 is as good as you can get for a fit, and R squared equals -1 is a perfectly good fit as well. And you'll learn all this in statistics next year, if you choose to take statistics. All right. All right. I think that's pretty good. So we talked about power functions. We talked about directly and indirectly proportional. We talked about all the different families of power functions, whether the exponents was like 2, 4, 6, 1, 3, 5, negative, or fractional exponents. And then we saw that you can find power functions by hand, and your calculator does it as well. So I agree, Rafi. It feels like Algebra 2. Feels good, right? No one's answering.
Yeah.
All right.
It's really good.
All right.